Hello, we are live. Thank you so much, Steph. I'll introduce you properly shortly. Welcome to Sydney Testers Meetup Group. Today, we do meetups usually every month, although we haven't done any for a couple of months now. Our meetup this week is with Stephanie Russell, who is based here in Sydney, and she's talking about combinatorial test data generation in TAFHub. So let me just show you a bit of an intro. So for those of you who are following us on Twitter, you can tweet us at Sydney Testers, or the hashtag today is SidSR for Stephanie Russell. Actually, Stephanie, do you have a Twitter you'd like to share?
No, I don't use Twitter.
Oh, okay, fair enough.
I used to. I put it to sleep.
All right, no problems. Let me carry on. So I'm sorry I got the name wrong and the times wrong. It's intro by myself and then taught by Stephanie Russell, not Josh Hill. And it's as you can see, it's starts for me to go on.
It's good to be up to date.
Check my slides more often. I'm so sorry about that, Steph. So who are Sydney Testers? We are a group of volunteers that focus on improving testing in Sydney. We organise monthly talks, socials and other events for the Sydney testing community, and we're now online. We have been online for just over a year. We have a wide range of local international speakers, including Michael Bolton, Zoe Tibbett, Sammy Connolly, Baz Dijkstra, some of the others that you listed there. If you want to get involved, we're always looking for people to join our exec and help us run events. We're also looking for people who are willing to speak at our talks. If you're interested in doing a bit of public speaking or have something you really want to share, just let us know. And thanks to our ongoing sponsors, TestEd. Okay, thank you. Steph, how are you? Thank you for speaking.
Yeah, good, no problem. It's my second time speaking at Sydney Testers.
Oh, okay, excellent.
But the first online. I've done the in-person ones.
Yes. Well, thank you so much, and always a pleasure. Let me just share your stream, your slides.
Yep.
Okay, cool. And I'll just do it.
Yeah.
So just for the people in the chat who are watching, if you have any questions, we will just post them in the live stream chat, so the YouTube live chat. And when Steph is able to respond, she'll let me know. And actually, Steph, do you want me to interrupt when there are questions, or will you say that you're free at certain points? How would you like to do it?
No, just interrupt me. That's fine.
Okay, that's fine. Well, in that case, what I will do is I'll interrupt you and show the question on the screen, yep. and then repeat it so that for you to answer it. There's no need to respond in the chat yourself, as we said. Just talk out the answer to the question. And also, if there are any questions at the end, I'll let you know, and we can answer them briefly, or you can respond to them. So once again, thanks a lot, Steph. You're a senior consultant at TestPro Limited, and
yep.
You're talking about this tool TAFHub for doing combinatorial test data management. Yep. All right, thank you so much, Steph. When you're ready.
Okay, so at TestPro, we have a number of customers, we always have, who are big into combinatorial test data. Thousands and thousands of rows, which we filter and combine in different ways. So it's something we've always done, but we kind of couldn't find a tool set that did it like we used to. We had an older tool set that we built in-house that has been very good for a long time, but we sort of deprecated it rather than maintain it. And so we've built a lightweight replacement, which we do use in projects, and we call it TAFHub. Okay, so what is combinatorial testing? This is my lightweight spin on it, but combinatorial testing uses, it's data-driven. So you identify the number of dimensions that are going to be in the structure of your test data, and you prepare the test data so that it represents every possible value of significance, not every possible value, but those values or those value ranges which are of testing significance. And then you generate and filter the resulting data, and you drive your tests. So typically you're going to have rows and rows and rows of test data, and you're going to have a test which is going to read each row and do the right thing, like either logging in as this user or buying this product or being from this state. And so it's combinatorial. So the tests are driven off the values in the result row. How large can these data sets be? Well, this is a bit of a made-up example, but say you had a state and there were 7 values, and even in New South Wales, there are 128 local government areas. If you took that as suburb, there'd be even more. You could say that there are age, next birthday, say if it was an insurance product in various age ranges. You could have an insurance product, life, property, motor vehicle, renter's insurance, and you could have an insured amount in ranges. And maybe what this test does is it just goes to their public portal and attempts to buy whatever kind of insurance according to this. Now, if you add all this up, that's 172,000 rows. And that's a lot of testing. And that's a lot of data preparation. So, and we do this, but we don't do all the rows. But you have to generate them and then you have to filter them. So it's good to have a tool. So the idea, ideally, would be 100% combinatorial test data coverage. And that would be to run all 172,000 tests. It might be the one test, which is going row after row, but still, you're logging in, you're buying something 172,000 times. But no one actually ever does that. So you could prepare all the driving test data in advance in a huge spreadsheet. And there are tools out there, free tools, that'll help you do this, but still it's a giant spreadsheet. And you could then start filtering it and running your test off it. Or on the other hand, you could prepare your test data in terms of each of the combinatorial dimensions. And then you could generate the driving rows at runtime with late-bound filters, which actually saves a lot of time preparing test data. So the way that TAFHub works is it doesn't generate these combinatorial test data structures in advance. It generates them at runtime as you request them using algorithmic mechanisms. So for example, if you did have a lot of rows, 172,000 rows, and you decided, well, I'm going to run tests because there were some recent rule changes for motor vehicle products in Victoria for people in range 3 of age, and just run those tests. And there might be 32,000 of them, and they might run 6 hours overnight, and maybe that's what would suit you. So TAFHub, TAF stands for TestPro Automation Framework. We just like to say that. It's kind of a number of tool sets we use internally on customer projects. This particular one that I'm going to show you today is 100% free. We build it for ourselves, but it doesn't matter. We're just happy that people get some use out of it, because as you'll see, the features are quite worthwhile. It comes in 2 ways. If you're writing, for example, tests for DevOps, so you're writing C# tests in Visual Basic, then TAFHub, you can just get it as a NuGet package. But we write a lot of tests in PowerShell, and to do that, NuGet's not really the best way to package. So we package it up as a zip file with all the necessary components that you can basically install into PowerShell. It works the same, but the syntax is a little different. So there are some key features. For example, TAFHub, you can, it's based on data sources. So you can say where all your different dimensions of data are going to come from before they're assembled into a combinatorial set. You can also create an empty TAFHub, and just in code, you can nominate data sources and the structure of data groups. So a data group is a way of putting together a number of sources in a particular order with filters to produce a data set you can drive tests off. So there's a number of ways of exporting results and exporting as-built data groups. And also, as you're running tests, there's also a mechanism which is very useful. For example, if you do, in say a first test, do 32,000 product purchases, and then you're going to get some kind of order ID from each of those, you want to be able to store them so that when your next test starts, maybe it needs to know what all the generated order numbers are from the first test. So passing them from one test forward to the next test, it's a very easy and convenient mechanism for that as well, because it's often what you're doing in combinatorial testing. So I'm going to do a demo of 3 basic views of TAFHub. The first one is C# tests in Visual Studio Pro. These are the kinds of tests you write for DevOps. Then I'll show you loading TAFHub into PowerShell, and we'll run some tests there just to show how it basically works. And then I'll show you the TAFHub analyzer, which is basically a validator for the pre-built JSON configuration that you can configure TAFHub with. And I'll show you how all that works as well. So there are some notes first, especially for PowerShell, and that is when you get the zip file, it's not going to work. It's not going to work because 1, you need to run PowerShell as an administrator. 2, it's not going to work because you've downloaded stuff and Windows won't let you use it. So you need to take all the DLLs and the PowerShell scripts, and you need to make sure that they're unlocked because they're internet downloads. Windows is doing this to you. It's not us. Next, in PowerShell, just make sure you've set your execution policy to unrestricted, because you don't want any itinerant, annoying security warnings while you're running scripts and tests. They're the basic 3 things you need to do. Be an administrator, unlock your resources because they're downloaded, and set your execution policy. PowerShell people will know what this means. Whoa, we're not there yet. I'm going to give you a demo now. So I'm going to change the sharing of my screen. And the first thing I'm going to do is use, can you see that?
See it fine? Sorry, it's still on the slides.
There you go. So
that's much better, thank you.
It just started up on the wrong screen. Right. So is that, can you see there's the is it too small? Is that visible?
If you could make it slightly larger, but it's kind of, I think it's all right on desktops. Maybe on mobile phones it might be a bit small.
I could unshare this and share my main screen, which is smaller. You'll be able to see it better, which I'm happy to do that.
Now, if it's going to cause any, if it could cause any disruption, then just leave it as it is. It's fine.
Okay, so in this case,
go to the video afterwards if they can't see it.
In this case, this is, I'll just lead you through the structure, very simple structure of how you use this. So one of the things we're going to do is open up. So we've got some stuff here. This is where I've installed TAFHub for use with PowerShell, so I'm not going to really look at that at the moment. But I've got these CSV files. In fact, 2 CSV files and an XLS. TAFHub doesn't care where you get your data from, CSV, XLS, or XLSS, doesn't matter, it's all the same. So what we've got here is, let's open these and just have a, just look at this one, for example. It's not meant to be very sophisticated because it's a demo. So we've got just name, color, country. And for this one, it's the same sort of thing, name, size, hobby, whatever that means. And product, which is a spreadsheet. The thing to be aware of is that in CSV files, it's just the file, but in a spreadsheet, it's the file and the tab. So down here, this tab is called test1, down here at the bottom. So these are going to be our three sources. There are two ways. You can either make a JSON file, which basically nominates what your sources are. In this case, the sources are, I'm going to call this one country. It's CSV, and that's where it lives. There's one called hobby, it's CSV, and that's where it lives. There's one called product, it's XLS, and that's where it is. But also in the product one, I've decided I want to use all the rows, so I don't like that shoe row. So I'm going to say select all from product where the product isn't shoe. So where it was in this spreadsheet, there's actually 6 rows, but I'm not using shoe. So this source will show up as only having 5 rows. We do that because one of the tools we have here is the TAFHub analyzer. And what it's going to do is it's going to validate and report on this configuration. Now, I've taken these sources and I've got a data group called DG1. So it's going to take the first source and the second source, and it's going to produce a combinatorial result. And the source that moves the fastest is the one that's on the left, and they get slower as they go to the right. So here, country's on the left and hobby will be on the right. In this case, it's all 3 of them, country, hobby, and product. But if you notice, one thing different about them is your sampling plan. So in this one, I'm going to use every row. In this, I'm going to use every second row up to a maximum of 7 rows. In this one, I'm going to use every third row, but in such a way that I take clusters of the next set of 3 rows and then choose one at random. And then this is true random. In this case, the limit I set to be 1000%, which means it's going to run out of rows after it's sampled your data group 10 times its size. So if you had 100 rows in your data group and you just kept plowing along, you're going to end up with 1,000 rows because it's 100, and then I said it's 1,000, so you can end up with 1,000 rows because it's going to keep sampling it up to your limit. Then there's random unique. The random unique is often really important to use because you don't want to be doing tests in a particular standard order. You want to do them in a completely random order, but you don't want any duplicates. So if you're going to be using a particular person to log in with a particular product that's implied by a particular row in your combinatorial data, you don't want to do it again. You only want to do each one, but you want to do them randomly. So in this case, it keeps track of the ones you've already used, and that's random unique. In this case, we're going to be choosing them at random. They're going to be unique, but we're only going to be using 10% of the set. So if there are 1,000 rows in your set, then we'll end up just doing the test 100 times, but they'll be random without duplicates. So if we go back to here, we'll show how this works. So in this particular test, we can see that this is Visual Studio. So what have we got? All of these other parts get sucked in automatically. The only one you really have to talk about is TAFHub, and by virtue of NuGet dependencies, all the rest get dragged in to support it. So in this case, this is a DevOps unit test. So we have test classes and test methods. And in this particular test method, we're going to create a TAFHub based on this JSON file, which we just looked at. So there's going to be 3 sources and 5 data group specifications. So we're going to open that. Opening a TAFHub is an important step because what it does is it takes your remote sources that could be off the network and the file system somewhere, and it actually reads them all in and makes sure that they can all be read and all the rows are distinguishable, and it then caches them in a local SQLite database. So all the operations that you do after the open are all happening on a local SQLite database. This is important, for example, when you're using DevOps, because the tests are running on test agents, and the test agents don't want to be going across the network all the time. So you suck in the sources that you need, you cache them in an SQLite database, and makes everything easier. So in this case, we're going to reset a reporting path. The reason we do this is because as we go through each of these rows, they're going to pass or fail. In DevOps in particular, whole tests pass or fail. And if your whole test is going to be doing 1,000 rows, DevOps doesn't know how to distinguish one row from another in terms of which passed and which failed. And so we have a mechanism for that. So you simply set where your test report's going to be. You pass and fail each row as you go around, and then that test report gets attached to the test result and it gets uploaded into DevOps, where it can be easily examined, opened up in spreadsheets, or included in reports. So what this does effectively is it says, okay, I get myself the DG1 data group, because that was defined in the JSON, and we start nexting through it. So as we next through it, what next does is it supplies the row to you as a standard .NET type data table. In this case, the data table that you get only has two structures. It's got the row that contains the data, and it has the header structure. So each of the rows has a name, and so the data table can be addressed by column name, which makes everything a lot easier. So basically, you're going to be getting a data table where the column names will be the same, but the data row, the single data row, will change each time. And in this case, all we're doing is printing it out. So if this is the first row of the data table, of the data group, well, it's first, and so we print out our data table with headers turned on. If it's not the first, we just print the data. Either way, we're going to report this row as passed, true. We don't have any logic to determine whether it's true or false. And if it's the last row, we're just going to say last row, and we're going to break out of the loop. But typically, you just keep going around this, grabbing the next row, and as long as you have a data table object that's not null, then you're pretty much good to go. We'll just close our resources, and the whole thing is wrapped in an exception handler, as you would with most tests anyway. So we can give this a run. We can see what happens. So let's just build this so I can see the tests. There's a whole bunch of tests. In fact, there are 11 tests, but right now I'm just going to run this one. Just to see what happens. So it basically said first row, it dumped the column headers. There's the first row. And as you can see, how Fred, biking, they're all the same because they're on the right. The data source that's moving the fastest is the one on the left. So it's combinatorial, right? So you could, for example, I know this is artificial, but you can have user ID or state or product, and you can have different combinations of product attributes that you use during the purchase process. And by combining them together, you end up with lots of combinations. So this is a bit of a simple example, but it shows you how they're put together combinatorially. And this is just two of them. And you end up with 68 minus 9. You end up with 60 rows, which we can tell because when we run the analyzer, it says country was 5 rows, but there was no filter. Hobby was 12 rows, and there was no filter. But as you can see, product did have a filter, And even though there were 5 rows in the spreadsheet, we're only counting it as if it has 4 rows. So it'll be combinatorially combined as if it's supplying 4 rows. And of the data groups, there's DG1, which is every 1. DG2 is every 2. And then pseudo, I called it. This is in groups of 3. You get 1 at random from the group of 3. So it tells you the maximum number of rows, the limit you've nominated, the estimate of the number of rows that will actually be returned to your test, and it calculates what your percentage coverage would be. Anything that's going to be every 1 is going to be coverage of 100%, unless you limit it. And here, every 2 with a limit of 7, well, basically it's going to be 2%. So it kind of gives you a, it reads your JSON file to validate it, and then it validates by reading all of your sources to make sure that they're readable, and it gives you an estimate of the number of rows each data group will supply to you. And sometimes this is a really, really valuable thing to do because you're tuning it. You know that I've got a 3-hour window tonight. I need to run, I know how long it's going to take. I need to run maybe 500 rows of test data. So what am I going to do in terms of my coverage goal? What should I change it to? Should I change my limit? Should I change my sampling plan? And you end up with, that's about 500 rows. It'll be good. So it's predicting how many rows you're going to get. And so when you schedule that, it's going to run overnight in a particular execution window. You know how many rows it's going to be. So that's kind of the way it works when you're writing DevOps unit tests in C# in Visual Studio. It's pretty easy to write. I'll show you how this something very similar works in PowerShell. So in this case, for this particular folder, I can just grab myself a PowerShell as administrator. Now we've got ourselves a PowerShell. So one of the things we're going to do is we have to install these resources into PowerShell. Now PowerShell has a very good .NET management interface. It's called Reflection. And so you can load any kind of .NET classes into PowerShell Reflection, and they all behave exactly like they would in any other programming environment. So we're going to load these into PowerShell Reflection. So to do that, what we're going to do is we're down here in PowerShell. We're going to run the setup. And PowerShell has said, well, you mean all these DLLs? You wanted them to be loaded into Reflection? And so it reports, yep, got that one, yep. GAC is a different sort of plug-in class management system in PowerShell, which we don't use. We're just using straight Reflection. And so, no, these are not GAC objects. So it loads them all in, and it's all happy. My session, my PowerShell session now has all of these DLLs and all of their classes now installed into PowerShell Reflection. So we can look at some samples. So here, where are my samples? Oh, they were in PowerShell. Right, so let's just run sample 1. Now in this case, sample 1 is just a sample. Like you should read it, go, haha, I know how that works, but I'm going to fix it for my environment. So let's take the sample and let's just fix it, because it's only a sample. So we'll take sample 1. And here, we'll just put our sample here. Edit it and see what it does. So this particular sample, it's pretty much almost the same test as you saw before, except it's using PowerShell reflection syntax. So we got $T for a TAFHub, we've got $DG for a data group. This is reflection syntax, but as you can see, I'm actually doing every stuff in drive E, not drive C, so I'll fix that. And it's a temp TAFHub, and that's where the JSON is. Yep, it's just I'm changing the drive. What else is different? DG1 is a data group in TAFHub, so I'll continue to use it. And pretty much apart from the while loop is different, you need to say $null, you use to minus NE for not equals. It's PowerShell. PowerShell syntax is a little different, but basically the classes all work exactly the same. So we can give that a run. So we'll save that. And here, we'll just go up to where it is. There's sample one. /. Produces the same result. And we actually use this for real customers. We have combinatorial data and we write systems integration tests in PowerShell, and it works just the same. And you get combinatorial data, and you can use all the other features. One of the things you'll notice hidden here is there's a README. The README you can also see on the NuGet site. But apart from the README, which is quite extensive. So it really tells you about all the features and how to use them with samples that could probably do with updating. The other thing that we have is about the TAFHub analyzer. So it tells you about that a little bit, about how to use it. And the other thing is that there's the user guide. The user guide tells you about each of the classes. And there's really only two. There's the TAFHub class and the data group class. But it tells you about the constructors, all the methods, all the parameters, how they're used, example source. So it's actually quite extensive in terms of how you use it. And of course, the other thing is it's completely free. Where is my here? The NuGet package lives here, which if I click on it, we should be able to see the NuGet package, which is this from TestPro. This is NuGet TAFHub 104. So that's pretty good. And the PowerShell zip file is just on our website under TAFHub. It's free to download. So here under Automation TAFHub, it's an introduction to it. It tells you where the NuGet package is. You can download the zip file and you can start using it for free. And pretty much, apart from questions, thank you. And that's the end of the presentation.
Well, thank you so much, and I really like that. He's a great little tool, actually, I have to say. Just opening it out for questions. Not had any yet, but I'm going to keep it open for a few more minutes to see if any questions come through.
Mm-hmm.
I was actually looking at it. One of the things I noticed is that it's the actual, when you see it, particularly in C#, which is a language I know best, I don't particularly know PowerShell. It is actually it is quite easy to, I mean, the class library, the different methods you call seem pretty easy and quite intuitive. So it does seem, you create your TAFHub, you create a data group, and then you kind of iterate through it. And,
pretty much, it's as simple as that. All the complexity is in having your sources in the first place, having them, breaking them up dimensionally into where's the dimensionality in your test data such that it will combine together combinatorially. And then just setting up your plan, how you're going to step through, because you can have test data that's going to generate 1 million rows, but you don't always want 1 million rows. So your data plan is how you're going to be exposing yourself through it, the row limit, when it's going to stop, whether it's going to be every 8th row, every 10th row, or randomly in 200 row blocks, choose one at random, another block of 200, choose one at random. That's really where the power of it is in your plan. And it's efficient because we don't generate the data group in advance like some tools do. They would actually generate 1 million rows, and it would chug along for an hour generating 1 million rows before it even started. No. We generate the rows dynamically, algorithmically, and it's a huge performance improvement when you're generating very large data sets.
I noticed in the JSON file that you use that you have support for SQL or a SQL type language anyway for doing selections of rows. Can you do that as well? I mean, I think ordering may be less. It's not something you particularly do here, but
this is SQLite. The documentation talks strongly about how the underlying structures that support this are SQLite, and so you have all the available SQLite syntax, including joins, order bys, everything. It's the filter you apply, and we only apply filters to each of the sources. We don't apply filters to post when they're combined, because that's a waste of time. The only time you actually want to apply filters is to the combinatorial parts before they're combined, and that's why we have filters at the source level and not at the data group level.
Thank you for that. What file types? This may be in the documentation. I'm sorry if I'm just repeating.
It's CSV, XLS, and XLSX.
Oh, okay. So CSV and the 2 Excel file types. That's great stuff. Thank you. Yeah. Can you sort of give us a bit of an example of where obviously within the limits of what you were able to talk about in public, of a particular project you've used this on?
Yes. There's a superannuation organization, which I won't name, which is we supply testing services to a large integration project that they're doing. And in that integration project, we use combinatorial generation of data in order to put transactions into the systems integration tests for exactly the reason I said, to create transactions of multiple different types, because they're managed differently within the integration, as well as it provides a background to be able to say that we actually managed all of these different transaction types and that they all got distributed to the right places. And so coverage over all the types of business they do is an important, an oversight of the integration project. So we use combinatorial test data generation to do that. In a previous project, there's a large bank, it's classically unnamed bank, and we use combinatorial test data extensively into the millions of rows, but they were then filtered. But that was with the previous tool. This is a son of, because it's been re-implemented, particularly because we have PowerShell projects and we have DevOps projects, and the old technology we used for combinatorial test data, it didn't translate. So we've rebuilt it, all the best features. We dropped the not so good features that we learned over time. We kept all the good stuff, all the core kernel features, and we've built it again, particularly for our DevOps and our integration test customers, where we use PowerShell.
Okay, that's excellent. Thank you. I just want to say I've been looking at the data, the documentation, the TAF data group class. One thing it does support, which I know the examples you use involve going through each row one by one. It does support an export where you can export all of the a combinatorially generated rows to a file, a CSV file. So maybe
yes, if you have a data group, then sometimes what you want to do is, I know I've generated this particular data group, and especially if you're using random or random unique, it says, well, I have a data group, but you know what? I know I'm only using 10% of all the rows, and I know I'm choosing them at random. I may want to do this exact test again. How will I know which rows I've used? And so you can export the data group, right? And then you've got your exact same ones. And if you've exported that data group as a CSV, you just bring it in again, right? And iterate over it again. Except now it's not combinatorial because it's just a single source. And if you every one through a single source, you're effectively replaying a previously combinatorially generated data group. But you're replaying exactly the same data that was used last time.
Okay, cool, thank you. And just regarding the report that's generated, the CSV file report, I think you showed an example of it before, didn't you?
Yeah, in this case, so these are the values of the rows. There's no headers on this because you're supposed to know, right? Like if this has been uploaded into DevOps and you find that if at least one row failed, maybe you could set it up so the whole test failed. And then this will be uploaded into DevOps. You can say, oh, look, a test failed. You go into the test, you open its row-oriented result, and you can search for where the fails are, and you go, oh, this failed. It failed because Reg from, did someone misspell Gold Coast? Yeah. Is that why it didn't work? Like,
well, of course, yeah.
Yeah, so you can see exactly what data was used for that row that caused it to fail. So diagnostically, you can go, oh, I don't understand why that failed. I'm going to try it manually. And so you go into wherever it is, the application, because typically the values in these rows are being painted in using Selenium. You can go to and say, I'm going to do the same thing, and you use the same data, and there's a red error message. What the hell is going on? So it tells you exactly what was used at the time it passed or failed.
One of the things I like about this tool, and I compare it to tools I've used in the past, things like Faker for generating test data, is that they can be a bit prescriptive about the kind of data that they use for the data generation. And so, but what you do is you leave that up to files. You leave that completely up to the individual. So the individual, in a sense, provides the files that get combinatorially generated.
That's right. You provide the sources. You cut up your important test dimensions, and then you provide the data. There's now a theoretical set, and then there's a plan for walking through your theoretically could be millions of rows set.
That's fine. So you have complete control, and I suppose it's really what people want. Just a quick question. What's the future direction of TAFHub? What sort of new features are you going to be added to it? Are you going to add to it? What direction for it?
Well,
have you made a decision on that yet?
No, there was some talk about this particular version of TAFHub. We deliberately kept it simple. Like, this is the simple one. These are the minimum features you need to be able to say it's sufficiently complete, but yet simple to understand exactly what it's doing for you. Also, the data sources are from file systems, so they're CSV, XLS, and XLSS. We could make it so that you could draw data sources from databases.
Okay, cool.
Where you'd nominate a table with some filtering SQL, and you could draw data from that. So we're thinking about that. Potentially depends where it goes.
What about maybe calling an API? Do you think that could be something in future?
Well, you do that in your test. It's not up to us to call APIs. That's what you do.
Yeah, I understand.
Right? It's your language. I'm just giving you rows. How you go about this? You're using Selenium, you're using AutoIT, you're pushing SQL, you're doing HTTP requests and you're using the data to generate XML or JSON payloads, we don't mind what you do with the data.
Excellent. All right. Cool.
Paint
Thanks.
it into a GUI. That's up to you. And that's the whole point. It's just in a loop. And then what you do is what you do.
Yeah. Sounds. Thanks. It looks really good. I can think of cases where I would, use this even in my current role. And it's I like it a lot. I don't have any more questions, and there aren't any more questions in the chat. So, would you, just to wrap it up, just to say, would you, if people want to learn more, how can they contact you?
My email address was in the back of the slide. I don't know if you want to attach the slide pack somewhere.
Share it again.
Is there somewhere I can drag the slide? I can't attach any files, can I?
You can just say it, and I'll put it in the chat.
I'll just share it again.
You can share it, or I can just type it.
Wherever it lived. Yeah. Right, so there's my email address, srussell@testpro.com.
You're not sharing it.
Oh, you're correct. I didn't. Is that sharing now?
It is. Thank you.
It is. Okay. So that's my email address. Happy for people to email me with any questions. And then that's just me on LinkedIn. I don't use Twitter.
Excellent. Thank you very much. I'll remove that, but it's nice for, at the end of the meetup for people are interested to share your details. But cool. Thank you so much for talking. I really enjoyed that. Just to say that we will be doing, we haven't got another speaker booked in just yet. We will be shortly. Actually, we have one on the, we have one in April. I tell a lie. But we haven't decided on a date yet. And I'll be letting you know about that shortly. To people who are watching. This will be by Paolo Lai. And also we will be, every couple of months at least, we'll be having a social drinks meetup for those of us based in Sydney.
Yeah, that was good last time.
It was, yeah. It was, the last week one was quite good, based in Parramatta. We will be taking it, it won't just be in Parramatta, we'll be taking it around the city. We may do another one in the CBD when more people get back to work. But certainly the Parramatta one was pretty good. Enjoyed it. It's really good to actually be able to network again and to meet people and chat about testing. And thanks. I've got a few questions from Matthew Sanson Rutherford, who's a member of our exec. I don't know if you know him. He said, "Thanks, Stephanie." And another question: how many came along? We had 4 people in the end, which is fine because it made for a nice convivial chat.
Is that 4 including us?
It was, yeah, 4 all 4 people altogether.
That's good. Well, people will watch it later anyway. They can stream.
No. He meant how many people came to the meetup.
Oh, you mean the meetup at Parramatta?
Yeah, that one. That's what he's referring to.
Yeah.
Yeah, how many people came along? We got up to 6 people watching this one.
Very good. And no questions. Am I that good?
Brilliant. We had one comment actually, which didn't make any sense. It was called VUM today. I don't know if that means anything to you. I don't know. I asked for clarification, but they didn't respond. So I don't quite know what that was supposed to mean, if anything. But it's been great. What we find with these meetups is because the link that people watch the live one remains the link that people can watch the recording, and so people tend to watch it afterwards, and you can get lots of people watching it, relatively lots of people watching it after the event in their own time. So it's you can say that 6 people watch it now or a maximum of 6 people watching at any one time now, but later on that number grows. That's typically what happens. So I can send you those statistics. But in the meantime, Steph, please stay on. I just want to wish everyone good night, and thank you for attending Sydney Testers. Please come to our in-person social events when we're doing them, and come and watch the next event that we'll be doing. We're currently scheduled for April. I'll let people know the date once we've agreed it. Thank you so much. Steph, please stay on.